world's human population is approaching a staggering 7.4 billion people. That is 74 followed by 8 zeros. And it has more than doubled during my lifetime. If we as adults think the world has got more crowded since we were children, that's not because of rose-tinted memories. There really are a lot more people. And the United Nations now predicts that the human population will continue increasing up to about 9 billion by the year 2050. This population increase is challenging enough, but these people will all need to be fed, and I'm going to talk about the simultaneous challenge to agriculture and food production because of the difficulties in predicting our changing weather as the climate changes over the same period. Many people will have heard about changes in the climate, which is often described as global warming, but there are also changes in the rainfall and, more importantly, changes in the pattern of the climate. As individuals, we find it difficult to detect these changes because we only experience the weather at our particular time and place. Climate change is often presented as a change in the average condition, suggesting that it may be a bit warmer on average or that the total rainfall may change a bit year by year. Most natural systems are resilient, that is to say, they can recover from relatively gentle disturbances. But increases in the frequency of rare and extreme weather are much more challenging. So why is this important for agriculture and food production? If a particular year is on average 10% drier or half a degree warmer than normal, this may have little effect if that difference is spread evenly throughout the year. However, if the difference in the average temperature or water supply is driven by a short period of extremely hot or extremely dry weather, the effect is much more serious. A short period of extreme weather can be so challenging that there could be yield reduction or even crop failure. To illustrate this, I want to show two sets of data. First, you can see the average temperature, the value in the middle of the bell-shaped curve. And then second, you can see what happens if everything just gets a bit warmer. The curve moves to the right and the average increases. But we should also look at the extremes, that is to say, in the tails of the distribution. The number of days when it is extremely cold is drastically reduced, whilst the number of days when it is extremely hot is drastically increased. These are much more important changes in the overall pattern of the weather than changes in the average, and they are much more difficult for crops to recover from. What is even more important is that our understanding of the causes of extreme weather is much poorer than our understanding of the average weather. This is not very surprising because we have much less experience of extreme weather for the very reason that it has been rare. In summary, crop production is influenced by extremes of weather, and it is the extremes which are the most difficult to understand and predict. Yet extreme weather conditions are becoming more frequent. They may be the new norms to which we will have to adapt.